Hello, welcome to the second video for section 8.4 improper integrals. In here I'm going to work a couple more examples. You can see the first example I already have up on the screen. The first example is taking the integral from 1 to infinity of 1 over x squared dx. And of course I think it's always beneficial to take a look at a graph of this if we can. There's a graph of this. You can see we're actually finding the area under the curve from x equals 1 out to infinity. So we can then go ahead and break this thing up into a limit problem instead, because this integral is improper. Remember, we have to change this to a limit as b approaches infinity of the integral from 1 to b of 1 over x squared dx. But I'm going to go ahead and write that as x to the negative 2 dx. You can see this is a really simple integral to take. Add 1 to the exponent, and we get x to the negative 1, and divide by the new exponent, so divide by negative 1, or we can make it multiply by negative 1. So that's the limit as b approaches infinity of that integral from 1 to b. All right, now when we apply our limits here, or the integration limits, you end up with, remember that's 1 over x, so negative 1 over x. So this is negative 1 over b. And then minus negative 1 over 1. And we're still taking the limit of that as b approaches infinity. And you can tell that this part, as b approaches infinity, that's going to 0. Meanwhile, that's a double negative, so that's approaching 1. So our answer ends up being that this is equal to 1. Okay, so that's example 3. I have another example for this video. Let's go ahead and go through it. So example 4, we want to evaluate the integral from negative infinity to infinity of x squared e to the negative x squared. And again, I think it's nice to take a look at the graph of this. Now, the graph actually leads us to believe that we have origin symmetry here. And actually, if you test this thing, I believe we do indeed have origin symmetry. But let's go ahead and work this problem as if we didn't realize that this integral had to be equal to 0 because the part below the x-axis was going to be equal to the part above the x-axis. So the first thing we need to do is we can split this up into two integrals going from negative infinity to 0 and then 0 to infinity. And I already have that typed up because it saves a little bit of room here. So see, we have this as the integral from a to 0 and then from 0 to b, where b is being split in the middle, is splitting this down, I'm sorry, 0 is the middle between negative infinity and positive infinity. Take the limit as a approaches negative infinity, and the limit as b approaches positive infinity for this piece. All right, now these integrals themselves aren't that difficult. Ends up being a pretty straightforward integral. Excuse me. I'm going to let u equal negative x squared. In that case, du is negative 2x dx. So this integral, I'm just going to do the integral by itself to its side. You notice both these integrals are the same. Ends up being negative 1/2, and then we'll put a negative 2 in here. So negative 2x e to the negative x squared dx. And once you've made that modification, you can see that's equal to negative 1/2 integral of e to the u du, which is negative 1/2 e to the negative x squared. And it would be plus c, of course, but we're doing limits of integration here. So for this one, we have a plus c. But when we plug it back up into here, we can break this up into, I'm going to go ahead and change colors. So that was just doing these integrals. So now we have the limit as a approaches negative infinity of negative 1/2 e to the negative x squared evaluated from a to 0 plus the limit as b approaches positive infinity of the same thing and, excuse me, so of the same thing and that's going from 0 to b. Okay. Now, let's start plugging in our limits here. So, plugging our limits of integration. So, a approaches negative infinity of, this ends up being negative 1/2 e to the 0. So, negative 1/2 e to the 0 minus negative 1/2 e to the negative a squared plus the limit as b approaches infinity of basically the same thing, but it's negative 1/2 e to the negative b squared minus negative 1/2 e to the 0. Okay. Now, let's evaluate these, taking these limits as a approaches negative infinity. So as a approaches negative infinity, this thing, negative infinity squared, would be positive. So this is going to a negative infinity, so this part is heading towards 0. All right, same thing's happening over here. This piece will be going to 0 as well. All right, meanwhile, this is heading to 1. So that's negative 1/2 times 1. This part, it's a double negative, that's heading towards 1. That's positive 1/2. So we have negative 1/2 for over here, plus positive 1/2 plus over there is equal to 0. All right, there you go. And that's exactly what we expected it to be, because we saw that we have this origin symmetry up here. Now, it'd be interesting to note if they asked for the area under the curve, instead, we take the absolute value of each of these pieces, and it would be 1/2 plus 1/2, which would be equal to 1, which seems to be a really common answer for these videos. Anyway, that's the second video in this series of videos for section 8.4. Thanks for listening. I will probably do another video for the exploration for this section. Look for that, and thanks again for listening.